Hello. So now we're going to graph this absolute value equation, okay? Okay. The first thing we need to do is we need to find out what the domain is. In this case, the domain will be from negative infinity to infinity, okay? And that's because in here, I can calculate the value of this expression for any real number x, and I can take the absolute value of any real number, and so there's no restrictions here, okay? Obviously, the next thing we would want to know, logically speaking, is the range, but we can't do that unless we know the corner point. Now look at this. We might want to use the formula that we got earlier, that if an absolute value takes the form f of x equals a times the absolute value of x minus h plus k, then the vertex is hk. We might want to use that, but we can see that here we can't. At least we can't directly. But we can very easily pursue the other technique. Okay? And that's exactly what we're going to do here. We're going to use our tried and true technique, which is that if we set the inside of the absolute value term, in this case 3 minus 2x equal to 0, it will give us the x coordinate that corresponds to the corner. Let's do that here together. 3 minus 2x, which is this, equal to 0. Okay? So now, I could do this one of two ways. One way is I could say, okay, I'm going to subtract 3 to the other side, then I'm going to divide by negative 2. Okay? But it's easier if I just add the 2x to the other side. And I get 3 equals to 2x. Okay? I'm now going to divide both sides by 2 so that I can get the x by itself. Okay, like this. Okay, like this. Now, this gives us just x equals to 3/2. Okay? So let me write that down here. That's my x coordinate of my vertex. Of my corner point, okay? Now, how do we find the y coordinate? We insert this x value into our equation, okay? Let's do that together. So to find the y coordinate of a point on the graph of an equation, we evaluate the defining expression of the equation at the corresponding x value of our desire, okay? So here I want to find the y coordinate of the graph of this equation at the x value 3/2. So what I do is I evaluate it with this expression, okay? So let's do that here together. Y equals 1/4 absolute value 3 minus 2 times 3/2 plus 2. Now I know that probably all of you, or at least a lot of you, have figured out, well, David, haven't you always been finding the x value of the intercept in such a way as to make the inside 0? And couldn't we therefore just say this is 0, and then say that 1/4 times 0 is 0, and then say that the y value must therefore be the 2? We could do that, okay? But I'm going to use this as an opportunity just to continue to reinforce the skills of calculating with fractions, because I think that it's extremely important to not let go of those. Okay, especially for any of you that are going to want to learn more math, having that comfort of switching between calculating with whole numbers, calculating with fractions, calculating with decimals, and being able to go back and forth, it's extremely important. Anyway, let me stop ranting and raving, and let's get to business. First of all, I want to calculate. I'm gonna calculate the inside over here, okay, as a separate calculation. Or let me put it over here. So let's pretend this is my scratch paper over here. I have 3 minus 2 times 3/2. The first thing that I observe here is that this is a whole number and I'm multiplying it with a fraction. Now, So what I'm going to do is I'm going to rewrite this whole number as a fraction. So I can say, okay, this is going to be 3 minus 2 over 1 times 3 over 2, right? How did I do that? Whenever I have a whole number, I can write it as a fraction by setting it as the numerator and 1 as the denominator. Here, I can now multiply these two fractions. I'm going to have 3 minus What's the product of two fractions? The product of two fractions is the fraction whose numerator is the product of the numerators of the fractions being multiplied, and whose denominator is the product of the denominators of the fractions being multiplied. So here, 2 times 3, that's 6. What's 1 times 2? 2. And then here, if you guys can see this, you guys can see, 6 divided by 2, that's 3. So I can see it's going to be 3 minus 3, right? And that's going to be 0. What we could have also done, so basically that's true as it is, but we could also see this as, and by the way, once you're there, you should really write it as 0 and be over with it. But I'm just going to use this as another opportunity to continue reinforcing calculating with fractions. So here, this is already a fraction. This is not a fraction. I want to set it as a fraction that has denominator 2. First, let me set it as a fraction. So I'm going to set it as 3 over 1, and I'm going to put it in parentheses. Next to it, I'm going to leave a space for a fraction that will be able to enable us to write it as a fraction with denominator 2. And then I'm going to bring down the rest of my calculation like this, okay? Now here, I want to ask, by what do I have to multiply 1 to get 2? So that these two fractions will have the same denominator. Well, 1 times 2 is 2, so it'll be the fraction 2 over 2. Now, what is this fraction? It'll be 3 times 2, which is 6, over 1 times 2 is 2, and then minus 6 over 2. And you can see that, of course, this will be 0 over 2, because once I have them on the same denominator, I subtract them by subtracting the numerators and keeping the denominator. And of course, 0 over 2 is just 0. Okay? So I can write this as 1/4 times the absolute value of 0 plus 2. What's the absolute value of 0? That's 0. 0 times 1/4, that's 0. 0 plus 2, that's just going to be 2 here. Okay? So that is going to be my, that's my y coordinate of my corner point. Okay? Okay. I hope you all have enjoyed that. And now we're going to move on to discussing what the range is and various other related issues regarding this graph. Okay? Okay. Okay, so for example, to find out what the range is, we need to find out whether this graph opens up or down. Once we got into corner point, we're basically done with calculating the range. We just need to find out if it opens up or down. So it is still the case that this number in front of the absolute value term will determine for us whether it opens up or down. In this case, you can see that it's positive. It's positive 1/4 in particular, but it's positive in general. If it's positive, that means it opens up like this, okay? So we can see that our graph is going to look like this, with this point having coordinate 3/2, 2. Okay? So we recall that the range is the collection of achieved of values of y that can be achieved by the equation. In this case, we know that because the corner point is the location of the minimum, given that this opens up, and since the minimum y value achieved by that corner point is 2, that means that 2 is the smallest point achieved by this graph in general. Therefore, the range will start at 2 and will go all the way up to positive infinity as it goes up like that forever. Okay? Now, we want to see if it has any X-intercepts. Now, you will observe here, I know that all of you know this by now, having seen my other examples, that if the y coordinate here is 2 and it goes up, then it'll never touch 0, because any number larger than 2 will not include 0. Therefore, there are no X-intercepts, okay? Okay? And so now, what we're going to do is we're going to find out what the y-intercepts are, okay? Let's do that together here. Okay. Now, to find the y-intercept, we set x equals 0 and solve for y, okay? So if I set the y equals 0, I mean the x equals 0 here, I'm going to get the following situation. So y is equal to 1/4 absolute value of 3 minus 2x plus 2, where the x has been substituted with 0, right? Okay. Because we set x equal to 0 and solve for y. Okay. Now look at this. What is 2 times 0? That's 0. 3 minus 0, that's just 3. So this will become 1/4 times 3, the absolute value of 3, plus 2. Okay? Now, what is the absolute value of 3? That's just 3. So this will be 1/4 times 3 plus 2. How can I calculate this? I can calculate it by writing 3 as a fraction. That is, by setting 3 as the numerator and 1 as the denominator. So this is 1/4 times 3 over 1 plus 2. Now, 3 times 1 gives me 3. 4 times 1, that's 4, plus 2, okay? What is 2 plus 3/4? That's 2 and 3/4. So I can already write that down as 0, comma, and 2 and 3/4. If I want to write it as an improper, I can continue that calculation over here. So 3/4, oops, I guess I just drew a Picasso there, okay? So that's 3/4 plus 2, okay? I can write 2 as a fraction with the 1 in the denominator, so it's 2 over 1. And then I'm going to have to multiply the 2 over 1 with a fraction such that the denominators will both be 4, okay? So it'll be 4 and 4 here. Now, if I want to multiply those, I'm going to get, first of all, the 3/4 comes down as is, the plus comes down. 2 times 4, that's 8. 1 times 4, that's 4. Once they're on the same denominator, I can combine the numerators, in this case by adding, and I can keep the denominator. Okay? What's 3 plus 8? That's 11. Oops. And what's the denominator? It's 4, like this. Okay? And if you were to look at this, and you were to convert it, 4 times 2 is 8, 8 plus 3 is 11, so you would get 11 over 4, okay? Okay, so we could write the y-intercept either as this, or what is the same thing, 0 and 11 over 4. As I mentioned before, I usually like to keep my fractions improper because it's nicer, it's more compact on the page. But if you want to have mixed numbers, or if you want to use the mixed numbers for graphing, that's completely acceptable, and yes. So now, we're in a position to graph this equation, this absolute value equation. Okay. 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 So if you notice, my y-intercept is at x equals 0 and y equals 2 and 3/4, and my corner is 3/2, or in other words, like 1.5, 1.5, and 2 up. Okay? So that means, and if I want to get another point, I'm going to reflect that way. So I'm going to need to go at least up until x equals 3. And my y will have to go up until about 2 and 3/4 or so. And so I don't need to draw that much. I don't need to draw that much of the negative part. I just need to essentially draw a little bit of the x part. So let's say 1, 2, 3. And then the y part, let's say 1, 2, and let's say 3 here. I'm going to drop these into quarters. So 1, 2, 3/4. So that'll be my 1, 2. That'll be 1, 2, 1, 2. And this will be my 3 here, right? This big line. Then here, this is 1s. These are going to be in terms of halves. So this will be 1.5. So this will be, like, let's say 1/2. This is 2 halves. This would be 3 halves. This corresponds to this line. This would be 2. That'll be 5 halves. And of course, it goes without saying that 6/2 is 3. And what I want you to see here is that I'm going to plot my points now from what we have here. And then I'm going to use the symmetry again to get my other point. I'm sure all of you have been already like figuring as much from the fact that I didn't make a table here. And in fact, we could make a table if we wanted to. And maybe I'll just calculate a couple of points to just to demonstrate that again. But no, yeah, I mean, we are going to calculate a few points on the table. But first, I want to have this graph done so we can at least have that accomplishment behind us. So the corner point is at 3/2 and 2. So I go to 3/2, which is here, and I go to 2, which is here. Okay, so that's my corner point. Okay, now my y-intercept is at 0 and 2 3/4. So 2 3/4. 1, 2, 3/4. Now notice, I went 1, 2, 3/2 to the left. So I'm going to go 3/2 to the right. So 1, 2, 3/2 to the right. That's at 3. And how high is it going to be? By the symmetry, okay, it's going to have to be 2 3/4 as well. So let me see if I get this right. Like about right there, okay? And now we can use our special ruler to draw these lines a little bit more acceptable so that they're more fitting, okay? Yay, it worked. Yay, it worked again. Okay. So now here I have my absolute value equation graphed, okay? But the question and in fact, again, I have all the points I need to verify that this is in fact the correct graph. You could see that we went through extreme care to make sure that it went through the correct x values and y values. In other words, the correct points. Okay, and again, this is like, again, I want to point out something else to you here. Obviously, you guys can tell that a lot of these problems are like textbook problems. That is to say that the numbers are always going to be like very nice, very small fractions that we can easily draw on a graph paper. But that's okay. That's good for developing intuition. That's good for learning what you're doing. Okay. But let's say that for whatever reason, so let's make a table here. And let's say that for whatever reason, you wanted to know the exact value at 1/2 or at 1, for example. Let's calculate those values here for my table, okay? So we already know that 3/2 is here, and it has the y value 2, so I can already put that in my table. I already know that I have the value at 0, so let's say I put that here, and that's of course 2 3/4. We calculated that earlier, which we can also write as 11/4 as we did here, okay? Okay, and in fact we can count that here. Watch this. Let me just make that point here. See, the point is 0 11/4. So 1/4, 2/4, 3/4, 4/4. That's 1. 5/4, 6/4, 7/4, 8/4. What's 8 divided by 4? That's 2. That's exactly what we see here. 9, 10, 11/4, which is exactly where it should be. Okay? Okay. Now we said, for the purposes of discussion, that we want to know the value at 1/2 and the value at 1. Okay? So I can plug those into this expression here. So let me do that here. Let's first calculate at 1/2. So y equals 1/4 times the absolute value of 3 minus 2 times 1/2 plus 2. Okay. So first of all, I'm going to calculate this inside. Now, so let me do that here. 3 minus 2 times 1/2. Let me see if we can see that. Okay, that's good. Is the same as 3 minus 2 over 1. Oops. Times 1/2. Right? Because we can write any whole number as a fraction by setting it as the numerator and 1 as the denominator. Now, what's the product of those two fractions? That's going to be 3 minus 2 times 1 is 2. 1 times 2 is 2. Okay? So that's 3 minus 2 over 2. That's the same thing as 3 minus 1, because we know that any fraction with the same numerator and denominator is 1. What's 3 minus 1? That's going to be 2. So I know that this becomes 1/4 times the absolute value of 2 plus 2. Okay? What's the absolute value of 2? That's just 2. So this becomes, therefore, 1/4 times 2 plus 2. Okay? Okay? So now we're going to do that on this side as well, so it doesn't mess up our beautiful graph here. Okay? So 1/4 of 2 plus 2. Okay? I can rewrite that as 1/4 times 2 over 1 plus 2. Now, I can look at this as 1 times 2, that's 2. 4 times 1 is 4 plus 2. Aha, they're not fractions. So I'm going to write this one as a fraction by setting it over 1. And then I can affix a space for a fraction, which I'm going to use there to form an equivalent fraction with the same denominator as the fraction I want to add it to. In this case, I want to make an equivalent fraction to this, an equivalent fraction to 2, but with denominator 4. So I know that 1 times 4 is 4, so that means that this has to be 4. And if I put 4 in the denominator here, I have to put 4 in the numerator here. Therefore, that's going to be 2/4 plus 2 times 4, 8. 1 times 4, 4. That's 8/4. This is ultimately going to become 2 plus 8, which is 10/4. Okay? And I can divide the top and the bottom by 2, and that'll give me 5/2. Okay? And that's my result here. Okay? So this will be 5/2. So then I can put that in my table here. 5/2. Now, does that make sense to us? Let's look at here. Now, we saw that it corresponded to 10/4 actually. So, and 1/2 is this line here, okay? So, 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4, 9/4, 10/4. And if we look at this and we go horizontally, we can see that that exactly corresponds to the point which belongs right there on the graph, okay? Which has x coordinate 1/2, y coordinate 10/4, or when we simplify it, 5/2. Okay? Now, let me just calculate what this would be at x equals 1, so you guys can see how making the table can help to fill in the values of the table in case we have any doubt. It just helps us, maybe we want the point at a particular value of x because of some problem we're working on, dealing with a physical situation. And of course, you know, maybe we just don't have anything better to do all day than to calculate the location where algebraic equations land on the x and y axis. You know, I mean, that's a possibility. I don't think that that's a realistic possibility, but it's also a possibility, you know. So now let's calculate it for x equals 1, okay? And also I want to, and of course also we're making the table because I want to remind you guys that sometimes making the table gives you some insight, okay? So here, it'll be 1/4 times the absolute value of 3 minus 2 times 1. Oops. Plus 2. What is 2 times 1? That's 2. Because anything times 1 is that anything. If we have 3 times 1, that's 3. 2 times 1, 2. 100 times 1, 100. 2 times 1 is 2. 3 minus 2 is 1. What's the absolute value of 1? 1. Okay, so we're left with, and what's 1 times 1/4? Just 1/4. Okay? And then plus 2. And we can see, aha, that's going to be 2 and 1/4. Now, if we convert that to, we can just look at it directly up here. Since we had broken this up into fourths, 2 and 1/4 would be here. And if we go up along the x equals 1 here, okay, and we go to the left, we see that it's a very good match, okay? It should be exactly, but you know I'm drawing this by hand. In any case, let me erase this for you so that it can look beautiful again. And then, here's my little table. Here's my graph. And let me make a few more discussion points about this graph here. Let me see what's going on here. Okay. So one of the things I also wanted you to notice is how I was very mindful about what x's and y's I needed. And also because I could see from where the graph was going to be located that it was going to be located here. So I could stagger where I place my my numbers corresponding to the axis here. And I could write these here so that it could make the graph extremely legible. By that I mean there can be no doubt that this is 3 halves, that this is the 5 halves, etc. So in other words, what I tried to do there was I tried to draw it in as visually clear and intelligible a manner as possible. And I wanted you to notice that because I want you guys to use those kind of same thought process so that your graphs can also be as intelligible as possible. Okay? I hope to see you again soon, and thank you so much.